to be a few differences that I make you do a little bit more advancedly than you've done in the past. So everybody pay attention. Because if you can't do this part, when we get to the right triangle trick, it's going to be super hard. So first of all, if you have a right triangle, that means there's a 90-degree angle in one of the corners. Then it creates a right triangle. Now, I call the Pythagorean theorem, I write it like this, because people get too caught up in what's A, what's B, what's C. A squared plus B squared equals C squared is what you usually hear. But you're going to hear me say this. Leg 1, so this is like one of the legs, this is another leg. Leg 1 and 2 don't matter. You can call this leg 2 and this leg 1. The legs can be interchangeable. This is called the hypotenuse. The hypotenuse is directly across from the 90-degree angle. That is a must. Everybody understand? So then we know that the Pythagorean theorem says leg 1 squared plus the other leg squared equals the hypotenuse squared. The important thing is that you remember the hypotenuse has to go on this side of the equal sign. Did you hear that? Did you hear that? Okay. So it says find the missing side. Just watch. You don't need to do anything. I just want you to watch. So first of all, what am I finding? The hypotenuse or a leg? The hypotenuse. So isn't it true to say leg 1 squared plus the other leg squared equals the hypotenuse squared? Okay, so now you'll do, everybody, I need you to participate. Let's go through this quickly, please. So you'll do, so this will be 49, because 7 squared is 49. I want to see your work. 49 plus 36 equals hypotenuse squared. You're trying to solve for hypotenuse. So our answer is 85. Good, you said that. 85 equals hypotenuse squared. Are we done? No, we have one last step. We have to square root both sides. Now here's the catch. Square root both sides of the equation. Now, in previous years, you were allowed to do a decimal. No longer in secondary 2 are you allowed to do a decimal. Nope. So we know how to break this down by hand though, don't we? If it breaks down, just like we've done with the quadratic formula, same thing, right? So we break this down if it breaks down. If it doesn't, we'll leave it as a square root of 85. So 85, everybody, can you find any factors? 5 and 17. Now, neither of those break down any further, so we can't break it down. Does everybody understand? So you multiply them back together, it's just square root of 85. So I want to see you write square root of 85, and then also, for practice, type in the decimal. So do second square root of 85, and you get 9.2. I need to see both, though. All good? Okay, another one, quicker. Now watch, this is where people mess it up royally. So first of all, am I trying to find the hypotenuse? No, I'm trying to find one of the legs. Maybe I'll just call it leg 1. So I have to set up a true statement. Leg 1 squared plus the other leg squared equals 8 squared. And now you're solving for leg 1 using algebra. So you would have leg 1 squared plus 36 equals 64. So 64 minus 36 is 28. Leg 1 squared equals 28. We're not done. And then we would break this down. 14 times 2, and then 2 and 7, right? So what we pull out of 2, everybody? 2 root 7, correct? So, yeah, and then 4 break, no, not 6 and 4. Yes, and then you can break down 8, and it'll break down the same. Wait, 8 and 4. 8 and 4, though, isn't 28, but you can break it down into any factors. What? So we'll pull out 2, though, right? We don't pull out 4, because it's the square root of 4, which is 2. Remember how we only pull out 2 for those 2 2's? Yeah. So you were saying that. 2 root 7, right? Everybody good? Oh, this is a 14. Sorry, 14 times 2. And then 7 times 2. So 2 root 7. So this is 2 root 7. And then also I want the decimal. So 2 and then root 7. Or you could literally just type in the square root of 28. But I need to see the broken down answer. This is what will be marked right on the test. So 5.3. All good? Next example. Okay, never mind. Do 7 through 22. We're skipping a little bit. So do the ones I assigned. 7 through 22, ready, set, go. Here's the general rule of thumb, though, everybody. Because listen, because this part gets confusing. If it starts with decimals, just use decimals. Meaning, you can just do the square root of 22.3. Because we don't know how to break that down. Does everybody understand? But if it starts with whole numbers, you need to do a simplified radical like in my examples. Ready, set, go. Okay, next example. So it says, this is the easy part. So it says, is the triangle truly a right triangle? So notice we're not finding any missing sides. We're given the sides. And notice we aren't given that it's a right triangle. There's no 90 degrees, right? But here's what we do know. Hypotenuse is always the longest side. So what's my hypotenuse here? 5. So you've got to say to yourself, if it's truly a right triangle, this is going to be my hypotenuse. So you've got to set it up right. So we're going to check to see if it is a right triangle. Because if it is, this is a true statement. 3 squared plus 4 squared equals 5 squared. That's a true statement. Let's see if it is a true statement. Do that in your calculator. What is it? 3 squared plus 4 squared is 25. Now do this in your calculator. What's 5 squared? 25. Does 25 equal 25? Is that a true statement? Yeah, so this is truly a 90-degree angle. Does everybody see? Yeah. That's easy. Now let's do this one. Which one would be my hypotenuse if it was a right triangle? 7. So the true statement would be 5 squared plus 3 squared. Does that equal 7 squared? 25 plus 9. 25 plus 9. 29, 30, 31, 32, 33, 34. 34 equals 49. Is that a true statement? No, so this is not a right triangle. Does everybody see what I'm saying? So we'd say no. We'd say yes. Pretty easy, right? Last example, it says given A is 7, B is 3.2, and C is 5.4. You're going to have to draw yourself a picture. Now, if it's written with small letters, that means side length. So you'll just draw yourself a triangle, and we don't have to draw it to scale. I didn't draw it to scale, but it doesn't matter. So I'm going to say, like, for example, 3.2. This looks like my longest leg, right? So I better put the 7 there, and then the 5.4 there. So then I do, obviously I didn't draw this to scale, because look. Well, oh well, who cares? So isn't the true statement 3.2 squared plus 5.4 squared would equal 7 squared? Because that's our hypotenuse, right? And then if it's a true statement, you'd say yes, but this one's a no. So it's not. Okay, that's it. Finish the worksheet, check it off, and then you can hand it in.